There is a version of the octopus you already know. It changes color in under a second. It escapes from sealed tanks in aquariums, crosses the floor in the middle of the night, raids the tank next door, and returns before morning. It uses tools. It plays. It recognizes individual human faces and holds grudges against people who annoy it. Scientists who study them describe a level of intelligence that feels wrong for an invertebrate, an animal with no backbone and a brain the size of a walnut. It is the cleverest thing in the shallow ocean, and in a lot of ways, it is one of the cleverest things in any ocean. That version of the octopus lives near the surface. It has ink, color, personality, camouflage, and what most people would recognize as a face. Go deeper, and things start to change. By the time you reach the bottom, the octopus has become something else entirely. It has lost its color. It has lost its ink. In one species, it has lost its body, or rather, its body has become transparent, a floating arrangement of organs with nothing solid around them. In another, it barely moves at all, drifting through the water like a ghost on ear-shaped fins. One of them holds its eggs for 4.5 years without eating, guarding them in the dark until it dies. The deeper you go, the more the octopus stops looking like an animal and starts looking like a question. Start at the surface. The common octopus, Octopus vulgaris, is the benchmark. It lives in coastal waters between 0 and 200 metros and has been studied more than any other cephalopod. In the wild, it solves puzzles, builds shelters from rocks and shells, and uses coconut halves as portable armor. In captivity, it distinguishes between individual human trainers, behaves differently toward people it dislikes, and has been observed squirting water at a light source that was irritating it. Its chromatophores, thousands of pigment cells controlled by direct neural signals from the brain, allow it to shift color and texture in less than a second, mimicking rocks, coral, sand, and other animals with precision that still baffles engineers trying to replicate it. The mimic octopus, found in the shallow sandy flats of Southeast Asia, takes this further. It does not just change to blend in. It actively impersonates other animals, flattening its arms to become a flatfish, arranging 6 arms into a burrow to imitate a banded sea snake, spreading its webbing to look like a lionfish. It decides which animal to impersonate based on what predator is approaching. This is behavior that requires recognizing the threat, selecting a response, and executing a physical transformation in real time. No other animal does anything quite like it. Then there is the blue-ringed octopus. It is the size of a golf ball, lives in tide pools and shallow reef crevices across the Indo-Pacific, and is almost certainly the most lethal animal you could accidentally pick up off a beach. Its venom contains tetrodotoxin, a neurotoxin produced by symbiotic bacteria in its salivary glands. That is, depending on the measure, somewhere between 1000 vezes mais potente que cianeto. A single adult carries enough of it to kill more than 20 adult humans. There is no antidote. The bite is nearly painless. Victims remain fully conscious as the paralysis spreads and their diaphragm stops working. Death is by respiratory failure, usually within minutes. The flashing iridescent blue rings that give it its name appear only when the animal feels threatened. A warning display that evolution has spent millions of years perfecting. When it is calm, it looks like nothing worth worrying about. All of this, the intelligence, the camouflage, the lethality, exists in the top 200 metros. Below that, the rules start to bend. Between 200 and 1000 metros, sunlight fades and then disappears entirely. Temperature drops. Pressure builds. The food is scarcer and harder to find. is the animals that live here have had to make choices, evolutionary compromises between what is useful and what costs too much energy to maintain in an environment where energy is the scarcest resource. One thing that stops being useful is color. The chromatophores that make a shallow octopus so extraordinary are metabolically expensive. They require constant neural investment. In a world with no light, there is nothing to hide from and nothing to communicate with using color. So the deep octopuses lose them. Their bodies become brown, gray, or translucent. The whole machinery of visual display that defines the shallow species simply disappears. Ink goes with it. The ink sac serves one purpose: to blind and confuse a predator in a visual environment. In permanent darkness, it is a redundant organ. Most deep-sea octopuses have either reduced ink sacs or none at all. When an Era Ove encounters a Dumbo octopus at 4 metros and approaches closely, the animal cannot release ink. It can only float slowly away on its ear-like fins. That brings us to the Dumbo octopus, genus Octopuses, 13 à 17 known species, depending on the taxonomy, found at depths between 1000 and 7000 metros. The deepest confirmed sighting was at 6.957 metros in the Java Trench in 2020 during an expedition that almost accidentally captured the footage. At that depth, the pressure is roughly 700 times greater than at the surface. The water is just above freezing. No sunlight has reached it since the Mesozoic. The Dumbo octopus looks like something designed to be non-threatening. It has 2 prominent ear-like fins above its eyes. Fins, not ears. But the resemblance to the Disney elephant is strong enough that the name stuck. Most individuals are 20 to 30 centimetros long, though the largest recorded specimen reached 1.8 metros and nearly 6 kilos. It moves by slowly beating these fins, hovering and drifting at near zero speed, an adaptation forced by the scarcity of food at depth. The high-energy jet propulsion that shallow octopuses use for quick escapes would be metabolically unsustainable here, where a meal might come once every several days. The fins allow continuous, slow, low-cost movement across large volumes of water. It is the most efficient way to search an environment where the next meal could be anywhere. It has no ink sac. It cannot change color. Its body is gelatinous and soft, built to be neutrally buoyant and pressure-tolerant rather than muscular and reactive. Its enzymes function at temperatures and pressures that would denature and destroy the proteins in almost every other animal on Earth. It has no gas-filled spaces in its body that could collapse under pressure. It has been shaped over millions of years into an animal that is perfectly suited to a world that would instantly kill most things that entered it. And in exchange for that suitability, it has given up almost everything that made the shallow water octopus recognizable. But the Dumbo octopus still has a body. You can still look at it and identify it as something. The glass octopus cannot offer you even that. But Vitrellodonella richardi inhabits the mesopelagic and bathypelagic zones, roughly 200 a 4 metros, in tropical and subtropical waters worldwide. Adults reach about 45 centimeters, including their arms. There have been very few sightings in the wild. Most of what was known about the species before 2021 came from examining the gut contents of its predators. Then, the Schmidt Ocean Institute's research vessel, Falkor, captured the first high-quality footage of 2 individuals in the remote Pacific, and the footage circulated widely online for one reason. You can see straight through the animal. The glass octopus is almost entirely transparent. The body wall, the mantle, the arms. All of it is reduced to a clarity so complete that open water reads directly through it. The only visible structures are the cylindrical eyes, with the optic nerves and the orange-brown mass of the digestive tract floating at the center. Everything else has essentially become window glass. Its eyes are not the large round eyes of a shallow octopus. They are rectangular cylinders, oriented to minimize their silhouette when seen from below, where bioluminescent predators might look upward for a shadow. The transparency is not camouflage in any traditional sense. It is more like the animal declined to develop an exterior surface at all. It made itself into something that simply does not exist visually. Even the eyes are shaped to be as small a target as possible. Something is happening here that goes beyond simple adaptation to darkness. The shallow octopus adapted to its environment by becoming more colorful, more complex, more cognitively demanding. The deep octopus adapts by becoming less visible, less substantial, less present. And the deepest strategies of all push this logic to its absolute limit. At 1400 metros in the Monterey Submarine Canyon, researchers from MIB eerie encountered a female Granelodone boreopacifica in May of 2007. She was on a rocky ledge, covering a clutch of eggs. They returned 18 times over the next 4 years. Every time, she was there, clinging to the same rock face, arms curled around the same eggs, in complete darkness, at near freezing temperature. The researchers offered her crab with the ROV's manipulator arm. She ignored it. She never fed. She never left. Over 53 months, by far the longest brooding period ever recorded for any animal on Earth, she tended those eggs as her body slowly consumed itself. Her pigmentation faded, while her muscles atrophied. By the end, she was visibly smaller and weaker than when they first found her. When the eggs finally hatched, she was gone. She had given everything to produce the most developmentally advanced octopus hatchlings ever documented. Young that could swim and hunt immediately upon emerging from their eggs, fully formed in a world where nothing they encountered had ever seen their kind before. The mathematics of the deep ocean are unforgiving. Food is scarce. Mates are rare. The cold slows everything, which means development takes longer, which means brooding takes longer, which means the mother must survive longer without eating. Granelodone boreopacifica's answer to this problem is to produce a small number of large, highly developed young rather than many small, helpless ones. Fewer eggs, more investment per egg, longer sacrifice. The strategy is so extreme that it extends the animal's lifespan beyond what any other octopus achieves. The brooding period alone exceeds the entire lifespan of most shallow species. There is something in this progression that is difficult to look away from. The shallow octopus is strange in a way that delights us. It is clever, it is playful, it is almost relatable. The deeper octopus is strange in a way that unsettles us, because it has been stripped of everything we use to recognize intelligence and personality and presence. It has become something closer to a phenomenon than an animal. Transparent, gelatinous, patient to a degree that has no equivalent anywhere in the animal kingdom. Moving slowly through permanent darkness in a body that barely exists, or carrying eggs for years through a world it navigates entirely by touch and pressure and the faint bioluminescent glow of whatever passes within reach. The shallow octopus is alien enough. Go deeper, and you find that the word alien starts to feel inadequate. What lives in the permanent dark of the ocean is not just different from us. It is different from everything, including the octopuses that live above it. It has been reshaped, stripped down, and rebuilt for a world that has no light, no warmth, no margin for error, and no record of ever having been seen. That is what the depth does to an octopus. It does not make it simpler. It makes it more extreme, in a direction we do not have a good name for. Creepier is the closest word we have. But what it really means is that the further down you go, the less the rules we understand seem to apply.